So welcome. As noted, I work for Autodesk. I'm a designated support specialist focusing on generative design in BIM, which is a really fancy way of saying I help some of Autodesk's largest customers adapt Revit and Dynamo and Refinery at a high level and make sure that they're successful in what they do. I do have to show this before I get going anytime I talk about something that is an active beta, such as Refinery is. So there it all is. What that basically sums up to is no promises made. Like water, all things may change. No purchase decide based on what I'm saying today. All right. Having said that, so a little bit more about me. I have my Bachelor's of Architecture from Wentworth Institute of Technology, the other IT in Boston. Spent about 10 years designing buildings before joining Autodesk. Been a user of Dynamo since the 06 days. I got some form stats on there. They're obnoxiously high. And you guys can find me on Twitter at Jacob W. Small.
Also now on Slack.
Yeah, also on Slack too, yes. Wanted to give you guys some baseline info in terms of what it is that I'm showing today. So we're going to do a quick crash course on setting up a graph for sort of conceptual layout of a modular building. All right, so why this topic? Glad you asked. So it's simple enough that I don't have to spend a whole bunch of time going too much over the geometry engine that's underneath it, but it's complex enough that it's still fun for me, and hopefully you guys can learn from it as well. Also found that it's a super common request. I get asked this like 3 times a week anytime I show Refinery, anytime I show generative design. People are like, can you lay out a hotel? And it's like, yes, I can, again. So here it is. It also levers pretty much all the must-know features of Refinery and fits well in the timeline where I had 20 minutes to get through all this. So some other tips before we start. If you don't have a good command of Dynamo, you're probably going to struggle with Refinery. All right, that may sound pretty basic, but there it is. Next up, speed is king. Only calculate what you need per run. Don't spend a whole bunch of time calculating something that you don't need right now, because when you do that, Refinery is going to do that for you, 10,000 times on some of these larger studies. So don't waste your time there. Remember as many semi-static variables as possible. Use minimal nodes, design script, and custom definitions and custom nodes really help out on that front. External resources are a super drain. Every time you have to go back to the well to get more water, it takes more time to fight the fire, right? So ideally, bring a bigger bucket or bring the right bucket. From there, remember, check your stuff in Sandbox. Errors will occur when you check it in Sandbox, but that's okay. Those same errors are going to occur in Refinery. If you get the right results and everything calculates, thumbs up, we made it. Gates are also really good to sort of help that out. Results must boil down to math. If you can't mathematically evaluate something, pass, fail, good, bad, 0, 10, you're probably going to struggle, right? So when we talk about, is generative design coming to take our jobs? No. Most of what we want to do as designers, it's not find out whether or not we fit all the boxes into the project. We want to fit the boxes in a way that's aesthetically pleasing and makes a good environment. All right. On to the next one. So this is my process. Yours may be different, but this one is mine. Do what works for you, but these are some tips as you get going. Every graph I more or less do this way. Study the problem. If I don't yet know the problem at a very high level, I'm probably going to automate stuff to do it the wrong way, and that's going to eat up more of my time. So do it by hand before you get started. As you do it by hand, jot down what you're up to, write down what you did as you go, and then build a map from your notes. Phone a friend, have them review it, get somebody else to review your map before you start. My coworkers, Ali and PJ, back in Boston, spend a lot of time looking at my whiteboard saying this doesn't make sense, or this is great, or more likely, why are you bothering me again? And then anytime once you're done with that, look over the parts of the map that you know how to do and the parts you don't. More specifically, the parts you don't. If you don't have a clue, do some research on that. Go ahead, search the forum. Say hello to me, like a few more of my posts, whatever else, and then figure out what that biggest rock is and come up with a plan for how you're going to move it. Also, always start developing your graph with a smaller data set. Don't try and eat the elephant at once. Your computer will spend a whole bunch of time calculating all 10,000 door locations in the project. If you can make it work for 5, you can probably make it work for 10,000. Start with 5 to 10 items deep in your list. All right. So my manual sketch, this is literally the process I went through on the whiteboard. I said, okay, I've got my buildable area. I'm going to convert that to a surface. Then I'm going to put a few points on that surface. Then I'm going to connect the dots. Then I'm going to offset that resulting polyline to get a hallway curve and then a building exterior. Then I'm going to find the exterior walls, right? Not the end walls. I don't care too much about those because units don't typically go on the end. Then I'm going to figure out how many points I can get based on my unit width on each one of those end walls. Then I'm going to find the nearest point on the associated hallway wall. And then with those sets of points, I'm going to play connect the dots. I can then take that length for every one of those. And if it's longer than my unit depth, I know I've got a problem and that is not going to be able to fit for a unit. Gets me something like that. I can then make surfaces for my overall building and my hallway, subtract the hallway from the overall building, gets me some units, extrude those into a poly surface, take that poly surface, divide each one of those up by the units, find out which ones are too small, or too big rather, which ones are just right sized, and then add all those up to get good numbers. All right? Went through a lot there. Wow. Don't worry, it's all in the presentation, so we'll be able to get that out to you guys later. My end goal is to maximize the number of units that fit, minimize the amount of oversized units, and minimize the amount of almost right-sized units. All right? We want to waste as little square footage as possible. This is what that works out to when I wrote it all down by hand. All right? It's a bit messy. Sorry, I don't have the greatest handwriting, but don't worry too much about this because we're not here to talk about Dynamo. We're here to talk about Refinery. This is what the graph looks like when it's all said and done. Okay? All right, so what is Refinery anyway? Refinery is a way to control Dynamo. It literally just boils down to that. It's not doing any more or less. It's just controlling Dynamo. But there are some finer points. It basically allows your computer to go in and grab what your inputs are, adjust them around, just like we saw with Galapagos, find out what that end result is, and say, is this right or is this wrong? It's going to do so 6 times at once, right? So you hit run on your graph right now, you get 1 result. What if you hit run and you got 6 results? That's effectively what Refinery is doing. It does not have any connection to Revit or Civil 3D for any Civil 3D users, or Formit or any other host application. You are running Dynamo Sandbox, right? Under the hood, invisible, so you don't see it, but that's what's happening. Input values, again, are adjusted by Refinery, and outputs are recorded by Refinery at the end. So whatever we have in our last watch node that's marked as an output, you're going to see that when you're done. Now, again, there is no Revit connection, so remember to use your remember nodes. Content pulled from Revit, whatever it is, if it's an element, if it's a surface, if it's a parameter value, has to be remembered. Otherwise, when Refinery goes to run in Sandbox and starts that up, it's going to say, I don't know what a Revit element is, so you get null. So all your Revit API calls and everything else, everybody who's a big fan of the Python nodes and graphs, right? Those are great. However, if every one of your Python nodes has in your template, load the Revit API, well, now you're going to be editing all your Python nodes to remove that, even if you don't touch it. So keep that in mind. You can't access any of that Revit data, whatever it is, if you didn't bother to remember it. Speed is also important, so disable any creation for your typical recording stuff. As we mentioned before, the data gate node will take care of that. The value has to be set to off as well. And then nodes which call third-party APIs that leverage multi-threading can cause issue with Refinery. Again, we're spinning up 6 instances of Dynamo Sandbox in the background at the same time. That means we need all of those processors. Please don't take them away from us, otherwise we don't know how the software will really get the results back in the right way, usually the wrong way, so watch those carefully. So this is the data remember node. You can see it up here in the right-hand side. This graph looks pretty much like what you'd expect to see. I have property line, I'm able to get geometry, I remember that, this leads to that, same content, right? But what we see down here are the unresolved nodes. And those are outputting a null value, right? Because we don't have that package, we get nulls. But because the data remember node actually serializes all that data that we feed into it, into the DYN itself, whatever that data is, if Dynamo can remember it, it will, or if Dynamo can read it, it will remember it. It gets serialized into the DYN, so now I have access to that even though I don't have access to Revit, okay? Which is really cool. This does allow you to move stuff between host applications. So if you guys are working in Civil 3D or whatever else and you want to move stuff over into Revit, this is a great way to circumvent the system. All right, data gate is the other kind of big one. That's this node right here. As you can see, when it's opened, it actually passes the level element that I fed into it, and that continues to pass through. If I close that gate down here, turns it off, I get it just passes a single null. That single null executes like that, super fast, all the way through the rest of the graph. Yes, there's some compute, but it's not real compute. It's basically over and done. All right, some additional things you must do. Seriously, this won't work if you don't do this. Do not pass go, do not collect $200. Take the time to do these steps, otherwise you'll wind up on the phone with one of my colleagues saying it's broken, it doesn't work, what do I do? So number one, define and name your inputs. You have to tell Refinery which inputs are gonna vary. Otherwise, it's not gonna know what to change. Okay, so make your names clear. Your inputs have to be number sliders for now. They could also be integers, but typically just use the number slider. Make them clear but short enough. If it's a super long name, like this is the first column that I'm going to place U value, that's too much, right? I'm standing in front of the screen, you guys can't see. U value column 1, right? Call 1 U. Even better, right? As simple as you can get it where it still makes sense. Try and gather all the inputs all on the leftmost portion of the graph, put them in one group. This will make it easier when you go back into manual adjustment. You can also feed them into a dictionary and pass your dictionaries along. Dictionary is another key for speed because it does not, basically it just gets faster. We'll leave it at that. I don't have time to get into why, but dictionary will make things much faster. And then make sure the minimal characters, like I said before. Same thing goes for your outputs. You have to define and name your outputs. Yes, you can use nodes which give you a single number as an output, but I recommend not renaming those nodes. Instead, use a watch node and rename that. And again, all the way on the right to grab later. All right, so there are 4 methods for doing studies. Once you get in there, randomize, cross-product, like this, and optimize. Randomize, literally, it is what it says. It's going to randomly select values. It could be the right values, could be the wrong values. Probably it's the wrong. It's like rolling the dice, see what we get. There's no intelligence in these studies. All results are kept. So if you say, I want to see 100 results, you will get 100 results. But again, we're rolling the dice on how we get that. It's luck-based optioneering. The next method is cross-product. It sets up to 10 values dispersed evenly across your domain of your input. So if your input starts at 0, ends at 9, it will test all 9. If it starts at 0, ends at 100, you will not test all 100. You will test up to 10. All results, again, are kept. There is no intelligence in the studies. This is sort of brute forcing, show me everything. That's pretty much that. And then like this, it's kind of like randomize, only we're taking sides off the dice. Instead of rolling a 20-sided die and whatever sided die, we're going to limit the results to 25% of the overall domain. So if 5 was the right number on that 1 to 5, it's going to go to 7 and 3, let's say. And again, no studies, luck-based, but with sort of more of an assumed result. Next up is optimize. And this is where we get into an actual NSGA2 genetic algorithm, all right? Similar to the Galapagos stuff that we were talking about before. The difference here is only the Hall of Fame is kept, right? So when you go back and you go to the Baseball Hall of Fame or the Hockey Hall of Fame, we're in Canada, right? So when you go to the Hockey Hall of Fame, you're not going to find about every player that's ever played in the NHL. You're going to find about the All-Stars, right? This is what that is. These are the best performing, okay? Each subsequent generation learns lessons from the previous one, all right? So you wind up with a much better result at the end. On to how to actually use Refinery into some of the picks and clicks. Step 1, you got to export the graph, right? So you do this from within Dynamo. You can see up at the top. You get the Refinery option up there, and then you say export for Refinery. What that pops up is this handy window here. It's going to tell you where it's going to save it, and it's going to save a new version of the graph plus all of its dependencies. Those custom nodes and packages all get saved there as well. Then you hit export. Graph will now be available in Refinery. Back down here in Refinery, click Launch Refinery, and you're good to go. When you do this, it does overwrite your previous export. So if it was perfect before and you really don't want to change it because we finished that project but we want to reuse it, save as before you export. Otherwise, you will lose some data, so we want to make sure we're careful with that. Once you're done with that, you're ready to launch Refinery, right down there in the bottom. Once you're in Refinery, start with creating a new study, either from Dynamo or within Refinery, where it says Create Study down at the bottom. Always name your study. Another typo there. Select a desired method and then adjust the settings accordingly. Within randomize, you want to choose which inputs are going to vary, the number of runs, and with seed, what seed value you want to use for your randomization. For cross-product settings, you want to adjust which inputs vary and the variations per input. Do we want to do 5 variations here but 10 variations there, so on and so forth. The like this settings, which inputs vary, the starting value, the number of runs, and the seed, so we get a little bit more. And finally, the optimize settings, which inputs vary, which outputs are the goals, which outputs are constraints. That's right, we can filter out versions that don't pass the structural analysis, which is pretty cool. Constrain the min and max values, population size, generations, and seed. A lot of stuff going on there, but here you have it. Once done, you're going to hit Generate in Refinery. You're going to see a screen that looks just like this. Sorry for the guys in the back. It's a little tiny, I know. But at first, you're not going to see anything. Then you're going to start to see results sort of pop up right in here. And then some more, and some more, as the genetic algorithm sort of combs its way through until you finally get to the very end. And what's again actually happening here within that overall scope, we eventually get to our Hall of Fame. Within our layout here, there's sort of 3 parts that you really need to understand once you've got this setting set up. The first one, right, which I'm going to point at this screen just to make things easier for everybody else. This is your image grid and your values. We can click on the button right up here to either show the image grid as you see here, or we could just look at the raw numbers by clicking on the little list button from there. The raw numbers, it looks just like an Excel spreadsheet or a schedule in Revit. The image grid looks like what you see here. Each one of these images is full 3D geometry. You can zoom in. You can't make the image bigger, but you can zoom in on a portion. You can rotate in 3D. You can pan and all that stuff. The next portion is down here. This is where you're going to get either your Cartesian coordinates, which is sort of a grid showing any individual study, what the values are for inputs and outputs, or your scatter plot, which is what we're seeing here. For a really big study that had a lot of conflicting variables, you won't see only 4 options on the screen. You'd actually see a whole sort of series of lines where an optimal value would be down here. But because the options were in conflict, we're never going to hit that perfect optimum. In this case, if I let it run a little bit longer, maybe I would have got there. Tough to say. And then last but not least is the details pane, which is this portion over here. Click on an individual study, either here or here, and your details pane will come up. From there, you can switch between views down here, and you can see all the information about the outputs, all the information about the inputs, and the larger 3D model as well. Again, navigable. All right, I already covered all that in talking over the other slide. So once you find one that you like, let's say we liked this guy, right? Because it had the best overall score, we can bake that stuff back into Revit pretty quickly. If you've opened Refinery through a Dynamo window, if not, you may have to go open Revit and then open Refinery that way. There's a little button down here that says Open in Dynamo. When you click that, it will open it in Dynamo with the settings as they are optimized for within that selected study. And then you can hit Run, open up your gate, which you can actually see I did there. Hit Run, and then it'll actually create your Revit elements if you've taken the time to write that graph. So you can see I've actually created rooms. I've sort of highlighted that room there that I picked on for the hallway. I don't know why I picked that one. Maybe not the best option. And then all the other rooms as well as room separation lines for our partitions. We could have done other options such as walls and stuff like that. In this case, it didn't seem worthwhile because we're just sort of getting into the overall scope. But I've seen people use this for beyond just this sort of stuff. We've done wheelchair lift optimization. I did that recently where we wanted to actually physically pick up a wheelchair and put it in the back of a car. So we optimized that for our own fabrication. We've seen what's the best way to lay out the program for a single family house or larger programmatic elements as well. Really any kind of problem that you can boil down to do these steps. Here's my logic flow like I showed at the beginning. And you can get the computer to go through and execute those results and then evaluate those results, count something or say, hey, we did good here, we did bad here. You can sort of get to run through this software. So yeah, this is sort of the larger view of the previous output. If you didn't find one you like, don't stop there, keep going. Review your discarded data set. You can see within your app data folder, so username, app data, roaming, refinery, you can actually sort through all the different values. So these are the 10,000 different options that were evaluated. Doesn't keep the graphics for all 10,000 for obvious reasons. Your hard drive would explode, but it does keep the results and the inputs that generated those results for all 10,000. So if you want to go through, do a little bit more study, you can do it there. You could also use Capture Refinery to kind of generate the quick animation for all the different stuff that you put up there. I've got a link to Capture Refinery later on. You can also update the graph to either reinforce the outputs or constrain the inputs within a different domain. If you're like, we were really good here, I wish we'd studied this segment a little bit further, you can force that. You can go back and do another study. You can also do deeper optimization runs, do some like this if you were pretty close but you want to see some more, or constrain the values, like I said, in a different way. All right. So in summary, this is kind of what the process looks like. And the reason we sort of see this, it's not getting rid of the designer. It's sort of giving you guys the option. When you step out into a design problem, there are infinite things you could do. You could do anything. And you have a general idea, but you don't necessarily know the way you want to go about it. Designing from a blank page is far more difficult than designing from individual setups. So don't worry, it's not that we're coming after your jobs. We're making it so that you can do better design, more design in less time. And it is overall still part of the process. And we're going to talk about that process on the next one. And then the last thing, no matter what you do, the computer's not currently at the point where it can measure beauty, right? So it can't measure the quality of a space. It can't measure things like that. It's really good at saying, yeah, the design won't fall down, but it's not good at saying, yeah, that column really shouldn't be there, so on and so forth. All right, so the overall process in the grand scheme of things eventually looks like this. User builds a Dynamo graph to generate an option. Within that option, the user has set up Dynamo to evaluate the results. Once we get the results evaluated, we're going to ship that off to Refinery and let Refinery mess with our inputs 10 times, 100 times, 100,000 times, whatever it is, over and rank the results for that first generation. And then we're going to tell Refinery, go ahead and keep evolving. Get better and better and better. And it's going to go through step 1 through 3 repeatedly until you get through the number of generations that you want. Then it's up to the user to select an option. And then they're going to integrate that option into Revit. Right? So it seems like a pretty quick process, and it is. What you don't realize is that we're already doing this as designers. If we wanted to put windows in a house, anybody ever design a house, small residential kind of stuff before? It's really painful going through and finding the right window for any given piece because every manufacturer is slightly different. You can optimize that to some extent now. You can find what those ideal goals are and study it at a much faster rate than what you were able to do before. All right, so some basic Dynamo resources. Again, bookmark as many of these as you can. I think we're going to see if we can get this out to people through a PDF or something like that later on. But basic Dynamo info, dynamobim.org. Getting started, the Dynamo primer. If you're just getting started with Dynamo, right? As so many people said they were. Take the time to go through the Dynamo primer. Don't skip anything, even if you feel like you'll never need it. I promise you're not doing it to learn how to place solar panels on a roof. You're doing it to learn about list levels and lacing. So definitely do that. Questions and help, you can go to the Dynamo forums or submit a support ticket. You've also got some additional node documentation or additional nodes available through the Dynamo Package Manager. Those are third-party products. Autodesk doesn't vet them, but they are freely available for your use. We've also got Dynamo Dictionary, the Dynamo Dictionary, which is dictionary.dynamobim.com, which tells you exactly how to use all your different nodes, as well as dynamonodes.com, which is third party. Again, that's where you go for documentation on those third party nodes, as well as some resources here on textual coding with DesignScript, as well as Python and the Revit API. And then for Refinery, which is really, again, what we're here to talk about. But again, you can't talk about one without talking about the other. So info and news is our Refinery beta campaign right up there, first link. The Refinery primer goes over everything that I just went over in 20 minutes, only it would probably take you a couple weekends to get through. And then our beta site's also up there to actually get and install Refinery. Go ahead and click on that link and register there. We also have some information on the space analysis package, which was put together as part of Project Rediscover to allow people to go through and redo the Mars office down the street, and as well as Capture Refinery that I mentioned before, and some information on Project Rediscover.